Now, if you see in the question, three types of timings are given: optimistic, most likely, pessimistic. But to find out the critical path, we have to find out expected time. So, first understand what is optimistic time. It is the minimum time an activity is expected to take if good luck prevails and everything goes right in first instance, and the chances are very less. Then we have most likely time. It is a time an activity is expected to take most often when it is repeated under similar circumstances. So chances are high of having most likely time. Then pessimistic time is the time an activity would be taking assuming unfavorable condition. So chances are also less as compared to most likely time. We have to find expected time, which is shown by TE for each activity, and the formula is optimistic time, most likely time, and pessimistic time, and their average. As the chances are high for most likely time, it will be 4 TM and 4, 5, 6. So this will give you the formula for expected time. So we have to find out for each activity expected time in the given question. Like we have the activity A, B, C, D, E, F and G. Activity is 1 to 2. So its expected time, find out the optimistic time for it. As it is given, it is 2 plus 4 multiplied by 3 plus pessimistic time divided by 6. So it is equal to 4. Similarly, we will calculate for others, like for B we have 3 and 2, then 7, 6, 4, 2. What we are to do? We are to show it in the path, like 1 to 2 expected time will be shown here. For B, expected time we have calculated, it is 3, for C 2, for D 7, E 6, F 4, G 2. Now we are to find out the critical path. There are different ways. I will teach you only one method today. What is the critical path? Critical path is the longest path in the network, and identifying the critical path is very important as it determines the duration of the entire project. If any activity on critical path is delayed, the entire project will be delayed. So what is the critical path? Longest path. How to find out? First find out all the possible paths, like from 1st to 6th we have 1 to 2, 2 to 4, 4 to 6, 1, 2, 4, 6. Another path is 1, 2, 5, 6, 1, 2, 5, 6. Another is 1, 3, 5, 6, 1, 3, 5, 6. Yet another is, okay, find out the total timings of all this. 4 plus 2, 6 plus 4, 10, 4 plus 7 plus 2, 13, 3 plus 6 plus 2, 11. Longest is this. So we have find out our critical path. It is 1 to 2, it is 2 to 5, it is 5 to 6. So you will tick mark here and you will write down the critical path has been shown in the network by double lines. That's all for today.